name is Prakash Rai, and I'm from Batch 36 AI. This is my presentation for the Big Data Programming Project under the guidance of our module teacher, Sir Siddharth Newpane. And in my project, I'll be addressing urban transport efficiency by building a predictive pipeline for UNL shuttle service using Clarkes of London data, which is this. This is the raw data which I took. And what I'm doing with this code ingest is I'll be creating a database to store in my SQL. I'll be creating a SQL database using this code. I will explain to you what I did, what I used. Let's start from the top. I imported Panda because of data structuring which I will need for this project, and this SQLite 3 for my database, and this elementary for parsing. I chose this over other libraries because it is lightweight and built into Python standard library. So that is why I chose elementary. And okay, let's go here. Why I define my namespace as txc? I name this because this transexchange file uses specific word web schemas. I must tell my Python exactly where to look for the tags, so that is why I chose this. And in this code 13, this is loop that targets this annotated stop point ref, and I am extracting the stop ID and the stop name. This creates a map of where the bus goes. This is for that. And this is loop extracting for this vehicle journey and departure time. This captures the schedule itself, the when of the transport service. That is what it records. And in here I created this because it connects to the SQLite. This code here to SQL, you can see. Using a relational database, I can create SQL from this, and it is best practice because it allows the ACID, complicate storage place, which is a bit complicated to use. And in here I use toSQL function to save my data frames. This converts my extracted list into organized table, one for stop and another one for journey. This is what it does. And if I run this, as you can see, this is a success data saved to SQL data transferred, which is this cannot be seen right now, but this has been created with the help of these codes. And let's go to analytics. Okay, let's go from here. In the analytics script, we connected back to our SQL data. This follows a modular architecture where storage is separated from processing. This is what it does. And in here, this is a vital feature engineering step. I used a lambda function to split the time string and converted it into a float. You can hear, for example, I took 330 becomes 305. This is what it does. To give a short explanation, and in this line of code, uh, yeah, since AI, since real world delays logs are often private, I simulated a Ross-Hauer effect using a sine wave and random normal distribution. I program it so that delays naturally increase during peak computing hour. What I mean by that is it looks which is the peak hour. And from this data, I could find that it was 8 a.m. to 5 p.m., which was the peak hour for people to transport, use transportation. And where in here, in this line of code, here is the machine learning implements. I define my feature X as the hour. Here you can see X as hour and Y as actual delay, which is the target, and hour was the feature. And in here I initialized and fit the linear regression model. This is the AI part of the project. Computer is finding the thread line between the time of date and the expected delays. This is what it does. And in here, uh, in this visualizing block, I created a scatter plot. And in here, this save file, by saving the chart as an image, I make it accessible for our front end dashboard without needing to rerun the ML model every time a user refreshes the page. This is what it does. Let's run this. As you can see, the departure time, actual delay, and predicted delay, all is shown. And this line of code also gave us this, which is the needed thing for our code that shows actual delays and departure times, prediction, everything. Let's go to this. This is the part where it will use Streamlit for users to use. I'll show you at the end here. In this code, I used st.setPageConfig to set a wide layout. This is standard for data dashboard to ensure the table does not look cramped and large monitor. I'll show you that after. And in here I used os.path.exist as a safety check. This prevents the application from crashing if the database hasn't been generated yet. A basic principle of a robot software design. And in here the queue stops here, tf stops, and journey tables. Because I used SQLite earlier, these queries are almost instantaneous regardless of the data size. And in here I use st.column. st.column, I use this to create a split screen view. The left side shows where the bus goes and the right side shows where they live. This gives the user a high level operational overview, which again I will be showing you at the end. And this line of code, Finally, I integrated the result of our AI module using a ST image. This ST image, I displayed the chart we saved in the previous script that allows the transport manager to see the predictive insight directly in their web browser. This image also I put it here, st.image for them because it will be easier for them. Let's run this. To run this, we have to do this in our terminal. It directly takes us to our code project. This service stop points, and this is scheduled departures, and this predicts if it get delayed or not. Yes, that's it. Thank you.